look at the concept or the intuition behind assuming friction's direction. Remember, if you have a problem of like two walls or two blocks or something and you end up assuming the direction of friction wrong, the entire problem goes wrong. So it's very, very important to get the direction of friction right. Let's see how we do it. So the concept, the underlying trick or the underlying concept here is you keep this one line in mind. Friction's only job is to oppose relative motion. So the reason why friction acts is to oppose this, is to oppose relative motion. So let's say your ground is at rest, right? Your surface is at rest. If I have a block here and if I apply some force here, right? Then with respect to the ground, if I place myself on the ground and I look at the block is appearing to move that side, right? The block is appearing to move that side. That's why on the block the friction will act on this direction, because the block with respect to ground, the block is trying to move that side, so friction is acting like this. In fact, on the ground also the friction will act, because the ground is so huge, this friction has no meaning, right? This friction has no meaning, but on this block it does have a meaning. Let's look at what happens when I have two blocks. Mass m, right? If I am applying a force here on this, right, then how will the relative motion of this capital M be with respect to small m? So if I stand on small m, what I will see is that capital M is trying to move that side, right? It's trying to move that side. So with respect to small m, capital M is trying to move that side. That's why friction on capital M is this side. So friction will oppose the relative motion. And if I stand on capital M, now because capital M is moving forward and actually small m is at rest, but capital M is moving forward, but if I stand on capital M, it will look as if small m is moving backwards. That's why on small m, friction is acting in the forward direction. What happens if I take another case? I have a block of mass m and small m here, and if I apply force on this block, how will the directions of friction be, right? So if I stand on this now, then how will small m appear to move with respect to capital M? I'm standing on capital M, small m is undergoing some force is being applied on it, so it will look as if it's moving in that direction. That's why on small m your friction is in this direction, right, and capital F here. But if I stand on small m, then how will capital M appear to move? Because I am on small m and small m is moving forward, I will not see small m moving forward, I will see capital M moving backward. So because capital M is moving backward, friction will act on this direction, right? Another important point, if at all there is ever friction acting between these two bodies, these two bodies, then those frictions have to be of opposite direction. They can't act in the same direction. If on one body's friction is to the right, then on the other body in contact the friction will be on the left. Now whether this gets right or this gets left depends upon this particular intuition that I gave you, that stand on the other body, look how the second body is behaving or how it's moving, and oppose the movement with the relevant direction for friction. So that's how you assume the friction's direction. That's the concept or the intuition behind it. Ajay.